So in this video, we're going to finish number 26. And I was saying that we're going to find it when we're going to do it with the z-score tables. You're going to go to the positive z-score table and find the area for 2.11. So what we mean by that is you're going to go to the z-score table and you have 2.1 and then 0.01 that will add up to 2.11. So then after that you will find the z-score for negative 0.4 and then here 0.05. So we're going to subtract this number, these two numbers, in order to get the area that is between them. So when you go to 2.11, I'm going to go to the positive z-score table. So this will be 2.1 and then you go over to 1, so you get 2.11. This is 0.9826. 0.9826. And then you're going to go to the negative z-score table and look for negative 0.45, negative 0.4, so negative 0.4, and then over to 5, and that is 0.3264. 0.3264. So you will subtract those two values. You will subtract those two values in order to get the area between those two. The area that is between those two values. So that will be in your calculator. It will be 0.9826 minus 0.3264 of 0.3264, and that will give you 0.6562. That is the difference is the area in between. Okay, 0.6562. So this is letter C. On the next one, they're asking you to find the area of the indicated region. So this one is the area to the left. So we're going to find that area. Then in order to find this one is 1 minus this whole area to the left. So for the first part, you're going to find the area to the left. The z-score, this will be negative 1.1 and then 0.03. So you're going to look that up in the z-score table, the negative z-score table. So negative 1.1, negative 1.1 over to 3. So you have to go all the way down to 0.1292, 0.1292. So that is this area here, 0.1292. Then you're going to go to the positive z-score table. Positive z-score table, and we're going to be looking at 2.0 and then over to 3. So that's 0.9788. So 0.9788 is the area to the left of 2.03. But we're looking for the area to the right. That's why in order to find this answer, we are going to subtract 0.9788 from 1. So 1 minus 0.9788 is 0.0212. 0.0212. So we found the area to the left of 2.0.03 to be 0.9788, but that needs to be subtracted. So the final answer will be the sum of these two areas. So we are adding 0.1292 to 0.012. So I already have that in here. So I'm going to do plus 0.1292 and it's 0.1504, and that makes it letter A for this exercise. So for question 28, assume that the random variable x is normally distributed. They give you the mean, the population mean, and the population standard deviation. Compute the probability of x being less than 100. So you have to use the z-score. You have to standardize the score by using this formula that will be provided to you. So you have to find the z-score, and they're giving you the x value is 100, the population mean is 80, and then we are dividing this by the standard deviation of 16. So this is 20 divided by 16. 20 divided by 16, that gives you 1.25. So the z-score here is 1.25. So in order to find this area, this is the same thing as finding the z-score being less than 1.25. Since that is an area to the left, all we have to do, you're going to go to the z-score table and look for 1.2, 0.05, 1.2, and then 0.05. That will give you 0.8944. So 0.8944, that will be the answer, because it is asking for the area to the left. So 0.8944 was letter C. Again, the z-score standardized table will be provided to you. Number 29, use a standard normal table to find the probability. IQ test scores are normally distributed with a mean of 100 and a standard deviation of 15. An individual's IQ score is found to be 120. Find the z-score corresponding to this value. So the z-score is x minus the population mean divided by the standard deviation. So the x is, the particular individual score was 120. The mean was 100, and close that in parentheses, and the standard deviation is 15. So this is going to be 20 divided by 15. So 20 divided by 15, that is 1.33. So the z-score is 1.33. So you're going to go to the table to find the area. So 1.3 and then 3 over to 0.03 will give you 0.9082. So, and it's asking for just the z-score. I'm sorry, here they're just asking for the z-score. They're not asking you for probabilities. So once you find the z-score, we're done. I was just doing more than it was being asked us to find. 30. Determine the sampling error. The sampling error is the grade point average for 10 randomly selected students from a class of 125 students has a mean of 2.5. Assume that the grade point average of the 125 students has a mean of 2.8. So the formula for the sampling error is the sample mean minus the population mean. So in this case is 2.5 minus 2.8. So the answer is negative 0.3. Letter A, negative 0.3. A random sample of 150 students has a grade point average with a mean of 2.86. Assume the population standard deviation. So the population standard deviation is 0.78 and has a grade point average. Students has a grade point average of 2.86. So that is your construct the confidence interval for the population mean. So this is the mean. So they want the keyword, the confidence interval. So you can use a calculator to find the confidence interval. All you have to go to stats and then test, and you can say that you're performing a z-test because you are provided by the population standard deviation. So we're going to go for the statistics, and the population mean is 2.86. We move this to the side, 2.86. Enter, and then the population standard deviation was given to you. Population standard deviation 0.78. The sample mean, they want you to have a population, construct the confidence interval for the population mean. So X bar, what is X bar on this one? I know your confidence has a grade point average of 2.86, so it will be the same thing. Assume the population standard deviation is 0.78. The sample size is 150. And I selected the wrong information, so it has to be calc or test, and we're doing the Z interval. I went to the wrong option. So the population standard deviation is 0.78, so it was feeding off the other one. The X bar is 2.86, and it's 150. Level of confidence that they want is 0.98. So enter. So that means they're asking you to construct the confidence interval. So the answer is right here, 2.71 and 3.01. So that will be letter Z. So you have to choose the Z interval. So you go from stat over to repeat the process. You press stat. Press the stat key, then you move over to test, and you will choose number 7 for the Z interval. And here you have to make sure that you use the stats. You choose the stats that must be selected. And then fill in all the information that is there, and when you calculate it, it will give you the Z interval right here. So that is letter C. So on number 32, in order to fairly set the flat rates for auto mechanics, a shop foreman needs to estimate the average time it takes to replace a fuel pump in a car. How large a sample must he select if he wants to be 99% confident that the true average mean is within 15 minutes of the sample average? So within, that will mean that it is your E, and they want a 99% confidence interval, and the standard deviation of all times is 30 minutes. So the sample, do they give you, so that is, the standard deviation of all times is 30 minutes, so that would be the population standard deviation. So we have to use a formula to find the sample size. So you are to find, in this case, they're giving you the standard deviation, 30 minutes, and this one is the margin of error, that will be the denominator, and the numerator. In order to estimate the average time it takes to replace a fuel pump, how large a sample must be if selected to be 99% confidence. So we're supposed to find the Z-score for 90% and multiply by the standard deviation. So the Z-score of 90% is 1.645. So that will be the Z-score times the standard deviation. And so this is going to be, again, the 99% confidence interval is 2.575. So in order to get this answer, sample size is 2.575 and multiplied by the standard deviation of 15 divided by the sample size, or the margin of error, that is 15. But we have to multiply by the population standard deviation is 30. I put it 15 in here, is 30. So in parentheses, 2.575 multiplied by 30 divided by 15, close the parentheses, square. So here I'm getting 26.52. So you always round up. This is 26.52. So we need to round up to 27. So this is D, is the final answer. So on the next one, they want you to find the margin of error. So find the margin of error. So to find the margin of error, since they're giving you the sample standard deviation, you have to find the t-score, multiply, I know it's divided by, multiply by the standard deviation, that is 2.2, no, divided by, let me look at the formula for this one. So the margin of error, the formula for the margin of error, it will be the t-score multiplied by the standard deviation divided by the square root of n. So the t-score multiplied by the standard deviation divided by the square root of the sample size. So the t-score, we'll have to go to the t-table, and you also have to find the degrees of freedom. Your confidence is 0.90. So it is 0.90. The sample size is 16. So 0.90 sample size is 16. So it's 1.746. I'm sorry, 1.753, because the degrees of freedom are one less than the sample size. So here, again, your sample size is 16. So the degrees of freedom are 16 minus 1, that is 15. So the t-score, you're going to go to 15, and then the confidence is 0.90, so 1.753. 1.753 multiplied by the sample standard deviation divided by the square root of the sample size, that is 16. So you don't divide by the square root of 15, you divide by the square root of the sample size, the 16. So you can enter this in the calculator. I recommend that you enter everything in parentheses. So 1.753 multiplied by 2.2 divided by second square root of 16, and close the parentheses, because this calculator opens an additional parenthesis inside of the square root. Make sure that everything that you open, you close it. So 0.96415, they usually want 2 decimal places. If you look at the choices, everything has 2 decimal places. So the right answer will be letter D. And that's it for this video.